Welcome to today's mathematics lesson, and today we are going to look at computation with decimals and fractions, particularly adding and subtracting of decimal. Earlier on we've looked at decimals. We've seen that the decimals make part of a whole just like fractions. And this time now around, we want to see how the addition and subtraction is normally conducted. Now, first, I want us to know that in addition and subtraction of decimal, it just follows the similar procedure of whole numbers. Where in this case, when you want to add or when you want to subtract a decimal or a whole number, you must line up the units, that is the tens, the hundreds, the thousands, and so on, in the same column, and then you add and subtract each column independently. Now, when dealing with addition and subtraction of decimals here, the routine is just the same. Let us consider this. Let us consider 514, 272, and 106. If we want to add this, so you'll find that this column here stands for ones, this one is for tens, and this one is for hundreds. So we add each column independently, and any extra we carry it over. So for example, this case it is 4 plus 2, which is 6. 6 plus 6 is 12. We shall have 12 carry 1. So 1 plus 1 is 2. 2 plus 7 is 9. So we shall have our 9 here. We have carried nothing. We have 5 plus 2 is 7 plus 1 is 8. So we have 892 as addition when we are adding all numbers. Now let me bring in now the decimals, similar figures, but the decimals now I bring in and you see how we shall approach it. Supposing the sum here was 51.4, then we have 27.2 and 10.6, and we are asked to add. Now we've brought in the decimal. Take note that the decimals, the place values are simply taken read right from the immediate digit after the decimal. So this is what we call the tenth. The tenths, then the hundredths, and so on. So here we shall add from the decimal side. That's where we start from. We don't start from the whole number side, from the decimal side. So 4 plus 2 plus 6 on the decimal side gives us 12, carry 1. Now the column where we have a decimal place remains. So the column for decimal place should just on the same line. So we have 12, and then we carried 1. The 1 come here, it is 2 plus 7 is 9, and then this one gives us 8. So we have 89.2. So what do we realize, or what should we know when adding decimals? We need to know the following, and I'll be explaining at any given time when we look at a point. First, when adding or subtracting decimals, the decimal point, that is the decimal point, and when we talk about decimal point currently, you should be knowing this is the dots that we have. We call them the decimal point. Decimal point and each of the decimal places must be aligned under one another. And let us do this. When adding or subtracting, decimal point and decimal places, these are places, must be aligned under one another. Now, we have decimal places, you see they follow each other under one another. Decimal places are following themselves like that. So, having done that, we look at the location. we say that the location of the decimal point in the answer, the location of the decimal point in the answer is directly in line with the location of each decimal point in the question. Now, from here to here, this is our question. And this one here is our answer. So you notice that the location of the decimal point in the question should be in line with the location of the decimal point in the answer, irrespective of how many decimal places exist in the questions. It must be in line. That is point number 2. Point number 3 that we should note is that once the numbers are aligned correctly, then proceed as if completing all numbers. Just the way we handle all numbers, we shall proceed as if we are completing all numbers in addition or subtraction. We have seen this. I brought all numbers here, and this is for the decimal. Just the way we applied this is the same way we've applied the decimals, putting in mind that we aligned them according to their place values. Then finally, if the numbers of decimal places in the number being added or subtracted are different, if the numbers of decimal places or of the numbers being added or subtracted are different, then it is helpful to place additional zeros in the shorter numbers or those ones with shorter decimal places to prevent calculation errors. What am I trying to say here? Look, for example, 2.571, 3.2, and 5.35. What I'm trying to say is this. The number which has fewer decimal places, we shall put additional zeros so that they can be in line with others. The reason here is that we don't want to have errors while we are doing our addition. Now, what we have here, the first one has got 3 decimal places. That is 1, 2, 3. The second one is 1 decimal place. The third one is 2 decimal places. To add, we cannot align this one here. We say the first alignment, the decimal point must be in line. Even for the answer, we already know the decimal point should be there. But now what's happening here is that the zeros are important. So here we shall expect you to bring in additional zeros. I'll expect you to bring in additional zeros. Now, why have I brought additional zeros there? So that at least we can have equivalent decimal places. But take note that zeros after a decimal place is insignificant. It is not changing the value of that number. But now it can assist us to do the addition as required. So we come 1 plus 0 is 1. 7 plus 0 plus 5 is 12, carry 1. Then 1 plus 5 is 6, plus 2 is 8. 8 plus 3 is 11, carry 1. And then we bring in 1 plus 2 is 3, plus 3 is 6, plus 5 is 11. So you find that our answer takes up this form with 3 decimal places. And take note how we used zeros to balance the decimal places. So we are saying that there are basically 4 points that we need to know when adding and subtracting these numbers. As we said, just to remind ourselves that when adding decimals points, each of the decimal places and the decimal point is aligned the way we saw it earlier on to the location of the decimal point of the question, and the answer must be directly below each other. Then once the numbers are aligned, then we carry out the operation, that is the addition and subtraction, in the similar way we do it in the whole numbers. And finally, in case we have those numbers with fewer decimal places, others with many decimal places, for the fewer decimal places, we shall add 0 so that they are equivalent with those ones with the many decimal places. And there we are, we shall be ready to carry out the addition. So let us look at questions and see how to approach these questions. Find 8.31 plus 9.3. In our solution, we say the first one, we aligned them, so we shall change the format and we write there 8.31. Remember, 8 is a column of ones, so 1 should be there. And then we have 5.93. Remember, this addition. What you notice is that make sure that all the decimal points and decimal places are correctly aligned under one another. The reason being that both of them are in the same decimal places. So make sure that all the decimal points and decimal places are aligned under one another. So we are looking at alignment of, we must align the decimal points and places. Under one another. Having done that, then we go. We add. 1 plus 3 is 4. 3 plus 9 is 12. Carry 1. When you carry 1, 1 plus 8 is 9. 9 plus 5 is 14. So our answer is 14.24. 14.24. This one is easier because the decimal places were the same. The decimal points were also. The number of decimal places were the same, and the decimal point, we simply aligned them together. 64.8 B, 64.8 plus 3.012 plus 5.94. So we have another sum, at least with a different number of decimal places. But what condition are we following? The decimal point should be aligned. So when we start putting up, and we have to observe the idea of the place values. So the first one is 64.8. This is the tenths. After the decimal point, we have the ones and then the tenths. For the second one is 3.012. 3 falls under the category of ones, so 3 will come here. The decimal point should be right below the other one. And then 0, 1, 2. And the last one is 5.94. This is supposed to be added. As seen earlier on, we noticed that if the number of decimal places is less than the others, we fill in with zeros. So the first one, we shall increase the number of zeros here and the number of zeros there, so that we have at least 2 zeros, the 3 decimal places for the 2. And this one we shall simply add another 0 here. Having done that, you realize that all our questions, we have 3 decimal places. There we go. We can now add 0 plus 2 plus 0 is 2. It should be right below each other. 0 plus 1 plus 4 gives us 5. 8 plus 0 plus 9 gives us 17. Carry 1. When you carry 1, 1 plus 4 gives us 5. 5 plus 3 is 8. 8 plus 5. This one gives us 13. Carry 1. Then 6 plus 1 gives us 7. So you'll find that you have your answer as 73.752. 73.752. The alignment of the decimal point will always remain. The number of decimal places depends on the highest decimal place. So this highest had 2. But if this last digit was just 0, it is insignificant. We can leave it out or we put it there. Now, what if we are subtracting these particular numbers? So we want to look at subtracting decimals. In this case, find 5.83 minus 3.12. 5.83 minus 3.12. As seen earlier on, the first step is to align our digits. So we have 5.83. The second part is simply 3.12. Remember, we are subtracting. Now, you'll notice that in this particular case, all the number of decimals are the same. The number of digits are the same. So when we align them, each falls below the other one. So what we require to do is to move on and do the subtraction. So each column is handled. So we subtracted 3 minus 2 gives us 1. 8 minus 1 gives us 7. We have not carried or borrowed any number. 5 minus 3 gives us 2. It is positive. So our answer, when you subtract, is 2.17. But let us look at another mixture of a number, 146.35. 146.35 minus 79.5. 79.5. This is our problem, and from this we need to come up with a way to arrange them according to the place values and now start our operation of subtracting. So the first one is 146.35. The second number starts from hundreds, so don't bring it here. It starts from hundreds, which means 7 will be here. Then ones we have 9, 10th we have 5. That's what we have, and it is subtraction. As we said earlier on, if the decimal places is less than the other figures, we simply bring in the zeros so that we have the equal number of decimal places. So that implies that at this point here, where we don't have a space, I'll put a 0. Here we go now. We can be able to start our subtraction. So 5 minus 0 is 5. 3 minus 5. That one you find is a bit impossible because 3 is less than 5. Then we look at the next column on the left, which is the column of ones, and bring 1. When you bring 1, it carries a value of 10 here, so that this one becomes a 13. So we take 1 here. What remains here is 5. So 1, when it comes here, it's 13. Therefore, 13 minus 5 gives us 8. What remained here is not 6, but it is 5. So we have 5 minus 9. Again, the similar situation occurs. 5 is less than 9. So we shall look at the next column where we have a 4. We borrow a 1 to add to 5. What remains here is 3. 3 remains, we borrow 1. So 1 plus, when we bring 1 where 5 is, it's a value of 10, it becomes 15. 15 minus 9 gives us 6. Now we don't have a 4 here, but instead we have a 3. 3 minus 7 again, it's not possible. So what happens? We borrow 1 from the next column of hundreds so that we have 13. 13 minus 6 will give us 13 minus 7 will give us a 6. 13 minus 7 will give us a 6. At the end of the results, you find that we have a 4-digit number that is 66.85. Now, what do we learn in this situation? You find that just the way we were handling whole numbers, if you have a smaller digit number subtracting a larger digit number, it is not always possible. So we normally look at the next column on the left so that we borrow from the next column one digit which carries a value of 10, and when we bring it to the other one, then it means that it will now be easier for us to carry out the subtraction, and it has affected this column of tenths, the ones, and the hundreds. You find this is very common in addition and subtraction of decimal. Is very common when you are dealing with currencies, because we have dollars which are always rounded off to the nearest 2 decimal places, and that's why it is when you have the knowledge of adding and subtracting decimals, you will be comfortable to add and subtract dollars in a very simpler way. So let us look at another, some 2 more exercises, and then we see. So the question is, find each of the following. Find the following. $47.81, 6.98, 3.52. This is our question. Take it very simple. In our solution, we need to arrange it. We need to place the order. So for the first one, 47.8 is from tens, then ones, then 8, 1. 6.98, 6 falls in the column of ones, so 6 will come here, and then 9 here, 8 there. The last one, 3.52, 3 falls in the category, okay, column of 1, so 3, then 5, then 2. We are adding. For this particular case, it is easier because number of decimal places is simply the same for all our questions. So when we do the addition, this is 1 plus 8 is 9, 9 plus 2 is 11, carry 1. When you carry 1, 1 plus 8 is 9, 9 plus 9 is 18, 18 plus 5 is 23. We have a 3, we carry a 2. 2 plus 9 plus 7 is 9. 9 plus 6 is 15. 15 plus 3 is 18. Carry 1, and 1 is added to 4, giving us 5. So for our question here, we are able to add and get 58.31. It was easier because the number of decimal places were the same. How about a situation where the number of decimal places are different? The number of decimal places are different. Let us look at this question. $323.71, 3.4506. $12.9. That is our number. From this, we need to arrange it, to place it in an order until we find the exact value of this sum. So, what follows? So let us write the first number, that is 300 in our solution. It is 323.71. Take note of the place values of each digits as we do this. This second one, we have 3.4506. The whole number is only on the column of ones. So immediately after it should be on the column of ones, we should be here. You cannot bring it here. You cannot write the second question as 0.4506. I want you to note this. The decimal point here and the decimal point here, are they in one alignment? No. What is the place value of 3? It is ones. What is the place value of 3 in the first one? It is hundreds. They are not the same. So each one should go in the right column. So instead of writing this way, 3 will be under the column of ones, then 0.4506. That is the correct arrangement. And the last one is 12, where 2 is for the whole number for ones, and then we have 1, so 12.9. We have it like that. We are adding. As earlier seen, when we have the spaces, then we shall put the spaces, fill with the zeros. So we shall have the first 0 here, the second 0 here. For this other one, with one decimal place, we have the first 0, second 0, and the third 0. So that we have equal number of decimal places. And there we are ready to go and do our addition. 0, 6, and 0 is 6. Then 0, 0, 0 is 0. 1 and 5 gives us a 6. 4 and 7 is 11. 11 plus 9 is 20. Carry 2. Carry 2. We are carrying 2. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 2 is 10. So it's a 0. Carry 1. 1 plus 2 is 3. 3 plus 1 is 4. This 3 for hundreds does not have any partner, so we maintain a 3. Now, our answer is 340.0606. Make sure all the decimal places are clearly shown. That is it about the addition. Let us look at a few questions on subtraction. So we have find, and the first one here, you are supposed to subtract, find 17.2 minus 17.2 minus 5.1. We are subtracting, so we align them in our solution. And in this particular case, we shall have 17.2 minus, we have 5.1. Take note of the arrangement of the decimal places and decimal point, each one below one another. So we are ready to go. The decimal places are the same. So we have 2 minus 1 is 1. Then 7 minus 5 is 2. 1 minus 0 there is 1. So when you subtract these, 17.2 minus that, you get 12.1. Now, for this case, it is easier because the number of decimal places were equivalent or equal. So it was simply easier, and the arrangement should be very important. But when you look at the next question now, I want to bring in a question where the digits are different, the place values are different. Let us look at this. 282.375 minus 159.483, and finally 72.689. Now, we need to notice this. In such question, let us look at the first digit. Is it larger than the rest? Because we are supposed to subtract the two of them. We are supposed to subtract 282.375 minus this one minus that. So we will notice that this is simply the same as, if I may rearrange it, this, if you do not have it, is the same as saying 282.375 minus, in bracket, 159.483 plus 72.689. It is the same thing. The large numeral, subtract the sum of the two. We want to subtract everything that we have here. So we shall approach this question in two ways. First, we shall look at those digits which we want to subtract in both cases and bring them together and add them. Then now we bring in the larger digit and subtract the way we are required. So let us consider the first ones in the brackets first, and then we come into the ones that are outside. So continuation of our solution here, we come here, we remove the brackets following the order. So that is 159.483 plus 72.689. When we add this one gives us 12. This one is 16, we carried 1, so 16 plus 1 is 17, carry 1. This is 10 plus 1 is 11, carry 1. This is 10 plus 2 is 12, carry 1. This is 12 plus 1 is 13, carry 1. This gives us 2. So we have added what is inside the bracket. Now we can come to our question and subtract. So it follows that 282.375 minus what is in bracket, and what is in bracket is the total, the summation of this one, 232.172. This one can now be subtracted. When we subtract this, 5 minus 2 is 3, 7 minus 7 is a 0, 3 minus 1 is a 2, 2 minus 2 is a 0, 8 minus 3 is a 5, and 2 minus 2 is a 0, which is insignificant. We cannot bring it here, so we maintain our answer like that. So we find that when you subtract these two numbers from 282, what you remain with is 50.203. 50.203. So that is it about the decimals. Now let us look at fractions. Remember we said earlier on that we have two that represents part of a whole. One is decimals and two is what we call fractions. We have seen how we can be able to add decimals, how we can be able to subtract decimals. Let us now look at fractions and see how able are we to add and subtract decimals. fractions. So adding and subtracting of fractions. As we saw earlier on, it is very simple to add fractions that have the same denominator, but it becomes cumbersome when you are adding fractions with different denominators. Why that one is so, we are going to look at it in this particular lesson. So, after a simple fraction is take for example, this will be a preview of this. This is, if you have a fruit, and then we happen to cut into two halves, which means this one will have a half like this, and then another half like this, then another half here, another half there. So this one is a half, a half, a half, and a half. When we are adding two halves, it should give us a whole number, which is 1. How does it normally work? Let us look at this. This a half plus a half should give us a whole number. That is practical when you do it. Let us bring it in figures and see, does it really work? It will be a half plus a half. If you add and say this is 1 plus 1 is 2 and 2 plus 2 is 4, this one will be wrong. Why? Because we have seen a half of one fruit added to a half of another fruit gives us a whole fruit, which is 1. Therefore, when we are adding fractions with the same denominators, we only add the numerators, but we maintain the denominator because it's just the half. So 1 plus 1 is 2. When you simplify 2 by 2, you'll get 1. So 1 represents a whole fruit. So when you're adding numbers with the same denominator, you make sure that the denominator is maintained and you deal with the numerator. Supposing it was a quarter. So we have a fruit here. Those are 4 quarters. One fruit has been taken and has been divided into 4. That simply means that when you bring the 4 of them together, what you'll get is like this. Which is a whole. This is a quarter, this is a quarter, this is a quarter, and this is a quarter, which means that when you add this one, you should get a whole, which is 1. So 1 over 4 plus 1 over 4 plus 1 over 4 plus 1 over 4 should give us 4 over 4. Remember, the same denominator is maintained, and then the numerator is added, which is the same as 1. That's why we are saying it is very, very simple to add fractions with the same denominator. So fractions can be simplified using addition only if they are like fractions. That is, they must have the same denominator. This means that they have been divided into the same number of pieces. These pieces are 4. And they are the same. Now, if 2 or more fractions have same denominators as we have seen, then we only require to add them by simply adding the numerator as we have seen and keep the denominator to remain the same. We added the numerator 1 4 times, and the denominator was maintained. The denominator is maintained. This allows you to find the total number of the divided pieces. You'll notice that even if we were to remove one piece here, then it will mean our fruit would be incomplete like that. And that one gives us 3 pieces of a whole. And when you are adding, you'll find that I'll get rid of that, and what I'll have here instead is 3/4. And that's why we are saying that when they are the same denominators, then they are trying to simply tell us how we are going to add the same number of portions. What if the denominators are different? Now, if the denominators are different, we must use the knowledge of the equivalent fractions. And to do this, we must make sure that we get what we call the lowest common denominator, the LCD. We saw it earlier on that we can be able to get the lowest common denominator, especially when we are looking for equivalent fractions. Remember, when we talk about equivalent fractions, this simply means getting another fraction which has the same value of the previous one. And we say to get equivalent fraction, we multiply both the numerator and the denominator by the same. For example, if we have 3/4, if we want an equivalent fraction of the same, if we multiply here by 3, multiply here by 3, you'll find that 9/12 is equivalent to 3/4. That's what we mean by equivalent fraction. So we are saying if the two fractions being added together or subtracted together are not of the same denominator, then the idea comes in that we must find what we call the lowest common denominator. What are the steps that we need to follow up in order to come up with this? The steps that we need to follow up in order to come up with this. So to carry out or to come up with the lowest common denominator, we need to observe the following. We need, if we want to find the lowest common denominator, 1, we shall be required to find that is, if we have the 2 or more fractions with the different denominators. For fractions with the different denominators, then 1, we shall be required to find the lowest common denominator. But now here, although it's not always, it is always easily found by multiplying the denominators, for example, but I've said not always, but you can easily get it. For example, if you are adding 1/2 plus 1/3, I've said we get the LCD here. And the leakage here, we are getting the hint that it is always easier to get the lowest common denominator by simply multiplying the denominators. And when you multiply the denominators here, it will give us 6 as the least common denominator. 6 divided by 2 is 3. 3 times 1 is 3. Then plus 6 divided by 3 is simply 2. 2 times 1 is 2. So it means that, before we move on, what we are realizing here is 1/2 is equivalent to 3/6, while 1/3 is equivalent to 2/6. That is true. So we have gone in for equivalent fractions to be able to simply add fractions with different denominators. And that's why now when you add this, you get 5/6. Now 5/6, we look at it keenly. As a fraction, it must always be in its simplest form. This one is already in its simplest form. So what am I trying to show here? that we must find the LCD, which sometimes we only multiply the denominator, but it is not always, as we shall see in the coming few examples. The second step when working out with the fractions of different denominators, convert fractions to their equivalent fractions with the LCD. Convert fractions to their equivalent fractions using the LCD. We have already seen it, just like I said, we were adding 1 over 2 plus 1 over 3. We simply found that what is the common lowest common denominator? We said 6. 6 divided by 2 is 3. 3 times 1 is 3. So if you don't want to write, 1 over 2, you simply say 3 over 6. Then equivalent fraction of 3, the denominator being the highest, the lowest common denominator, which is 6. 6 divided by 3 is 2. 2 times 1 is 2. So we are saying that convert the fraction to their equivalent fractions. That is 2 is equivalent to 3 over 6, and a third is equivalent to 2 over 6. So we have converted this one into their common equivalent fractions. That is what we simply have, and therefore we can simply maintain the numerator and add the numerator, and you get your 5 over 6. That is the step number 2. 3, add the numerators and write the total above the LCD. Add the numerators, and write the totals above the LCD. When we got the equivalent fraction here and the LCD as 6, then we said it's equals to, LCD comes down and then the vinculum line there. What comes above is the sum of the equivalent fraction, that is 3 plus 2, which comes here. So we are saying that add the numerators and write the totals above the LCD. That is what we have there. Now, after adding fractions, always look to see if your answer needs to be simplified. Very important when it comes to fraction. It must be in the most simplest form. Looking at what we have is already the simplest form. So these steps are the steps we shall always observe when we are operating the addition and subtraction of fractions. Let us look at questions touching on this. Add the following fractions. And the fraction that we are adding here, A, 1 over 5 plus 3 over 5. B, three over 11 plus 5 over 11 plus 6 over 11. Let us look at the first one. First thing I want you to notice is that the denominator is the same, or the denominator is alike. Therefore, we simply simplify the numerator. Add the numerators and simplify. So 1 over 5 plus 3 over 5 is the same as the denominator is maintained and the numerator is added. That is 1 plus 3, which is 4. So our answer is 4 over 5. 4 over 5. For the second part, when you look at our solution here, we find that it is 3 over 11 plus 5 over 11 plus 6 over 11. Now, the denominator is the same. Let us maintain the denominator because it is the same. But looking at the numerator, sum up the numerator and bring everything together. This is 3 plus 5 gives us 8. 8 plus 6, we get 14. So this one gives us the answer as 14 over 11. Or we can write as a mixed numeral, where 14 goes into 11 one time the remainder 3. That is under 3 over 11. Under 3 over 11. When we simplify the answer. Again, we've been able to work out this way because the denominator is simply the same or is alike. Let us look at other questions where the denominators this time are not alike. So, add the following fractions together. Add the following fractions together, and this time we have 1 over 5 plus 1 over 2 as our first question, and the second question wants us to add 3 over 4 plus 5 over 6. So, I want you to notice that the two questions that we have, their denominators are not the same. Now we are going to apply the 3 steps we saw earlier on when we are dealing with fractions which have different denominators. So in our solution, for this question of 1 over 5 plus 1 over 2, we must first find the LCD. We must find the lowest common denominator. And lowest common denominator of 5 and 2, using the hint we were given, is that it can also be simply found by simply multiplying the denominator. So you'll find that 1 over 5 plus 1 over 2 will give us the denominator here is 10. That is 5 times 2, which is 10. 10 divided by 5 is 2. 2 times 1 is 2. So fifth is equivalent to 2 over 10. And the second one, the denominator is 10. 10 divided by 2 is 5. 5 times 1 is 5. So we are saying a half is the same as 5 over 10. Now that we have the denominator as the same, let us add the numerators. So 5 plus 2 plus 5 gives us 7. So this one gives us our answer as 7 over 10. Again, you realize that the answer here is in its simplest form because there is no any common factor between 7 and 10. So we leave our answer at that particular point. So looking at the second one, again, similar with the case with this one here, but as we said earlier on that it is not always true that the lowest common denominator is just multiplied. This is one of the cases. Let us see. For the solution here, you notice that 3 over 4 plus 5 over 6. If we were to use the other knowledge, we would say that the LCD, that is the lowest common denominator, is simply 4 times 6, which is 24. No, that's not correct. We need to find the correct LCD. Why am I saying that? Because between 4 and 6, it shares a common factor. So if it shares a common factor, it means that we cannot maintain by simply multiplying. Let us find the lowest common factor for this. So I'll take on another space somewhere, maybe let me use here, and I want to have the numbers and the factors here. And then the numbers comes here. The number I have is 4 and another one is 6. So what is the common factor that can divide both 4 and 6? In this particular case, the least common is 2. 4 divided by 2 is 2. 6 divided by 2 is 3. What follows here is another 2. So that by 2 here gives us 1 and 3 is maintained. And then we come to 3, then 3 goes like that. So we find that our LCD is simply 2 times 2 times 3, which you said earlier on, it can also be written as 2 squared times 3. Or this one is the same as 4 times 3, which is equals to 12. Take note, if we were to multiply, we would use 24. But I've said 4 and 6 have got a common factor. So anytime if you come across a fraction whose denominators have or share a common factor, then do not multiply to get the lowest common denominator, but instead go the longer way of finding the lowest common denominator. So we have seen it is going to be 12. 12 divided by 4 is 3. 3 times 3 gives us 9 plus 12 divided by 6 is 2. 2 times 5 gives us 10 over 12. So equivalent fraction already have been generated. 10 over 12 is equivalent to 5 over 6. 9 over 12 is equivalent to 3 over 4. Now we can add. So 9 over 12 plus 10 over 12. The denominator is the same, so we maintain that is 12. Add the numerators. This gives us 19. When you have 19 over 12, this is improper fraction. It's an answer. You can still stop there and say that's the answer. However, if you choose to go and make it a mixed numeral, there's nothing wrong. 19 divided by 12 is 1 remainder, something like 7. So 1 and 7 over 12. This one is also allowed. So our answer could be any of that. So in fraction, when you are adding or subtracting or whichever the case, it is very important to study the denominator. If the denominators are the same, then it is much more simple because we simply operate the numerators. If the denominators are different, then it will require us to find the lowest common denominator. When you find the lowest common denominator, then what you find is that you simply get it easily by multiplying the denominators. But however, if the two fractions you have or more have the same denominator, they have got a factor, common factor between the two, then we use the longer way of finding the lowest common denominator. So that is it for today about addition and subtraction of fractions and decimals. Now, in the next class now, we are going to continue with the fractions and look at how do we go ahead and subtract fractions, and then we look at how about when they are mixed numerals. Thank you.